previous
Okay, sir.
there are three algorithms for non-recursion, right? One is finding number of digits in binary for a given decimal number. One is matrix multiplication, finding unique array. Third is finding maximum element in a given array. These three things we have signed. Today we are going to solve an algorithm that is finding number of digits in binary for a given decimal number. This you have seen the morning slide of this itself. This is what we are going to find. And let me go with the mathematical kind here, right? Assume that I'm having a number, say 16. I'm having a number 16, right? If I want to find the binary orientation of this number is actually in base 10. What is base 10?
Decimal. It indicates the decimal form of number.
So if we want to convert this decimal into binary fashion, what I'll do, I'll take this, I'll go for an L division method, that is taking LCM only with the 2, right? So 2 into 8, and my remainder will be 0. Join with me.
2 4 8, remainder 0.
Then I will multiply 8.
2 4 8, remainder 0.
2, 5, 4, it will be giving me again 0. Okay.
2 2's, remainder 0.
It becomes 0. And
2 1's,
2
remainder 0.
as 2, and I'll get the remainder 0. So if I go from bottom to top, it will give me the binary notation. So what is my binary notation? 1
1 0 0 0 0.
That is my binary notation, which is 1 0 0
0.
0 0.
Base
This is my
2.
binary. How many digits are there in binary totally? How many digits are there totally? 5. Five digits. So I name that. If I give a number 16, it should give me the output as 5. Similarly, if I give the number 12 in binary, how many digits it will give me? For 12 in binary decimal, how many digits will be there in binary?
4.
4.
4. So we need to find a problem. Now, can you say me how to write an algorithm for this? Yes, I write algorithm. Bin digits. Binary digit I mean as bin digit. And what will be the input for this binary digits? Shall I give a number n?
Yes, sir.
Yes, sir.
So now, what will be the input?
Number.
Yes, a number n. I'm asking you another question. Can this number be negative number?
Yes, sir.
Yes.
Yes, but you have to understand one term. When I take negative of the number, the binary number in negation will have the most significant bit as 1. Okay, those kind of stuffs are there. So you need to take care of those things also. And specifying the inputs, you should be very careful in specifying. For this problem, we can take either positive or negative. Okay, so I say a number n. Next output. I declare
Binary.
count. I declare a variable count. Okay, output is count, which is number of digits in binary or digits in binary of n. This will be the count variable. I want to output the variable count. Okay, so I'll go into the algorithm. The algorithm is very simple. You should take 16 and divide it again and again by 2. Now I ask you the question. Question number 1. Whether the inputs are specified carefully? Yes or no? Whether the input parameters are clear. What is the input parameter? What is the input parameter?
N, sir.
n. So your time complexity should be represented in terms of n. So condition one is fine. Second, what is the basic operation?
Modulus. Modulus.
You mean
Sum
modulus
of
or division?
digits.
Modulus or division? It is division, and I'm not interested in finding this 10000. I'm not interested in this number. I was interested in counting only. So this output I not record. Okay. I hope you understood what I'm saying. If I ask you what is the binary form of 16, you should give me 10000. I don't need this result. I just need the count. Whether it is 0 or 1, I don't mind. Okay. So I don't want to find this. I just want to find how many times it is being divided to get a value 1. So I want to repeat it. I want to divide the division operation again and again until what happens? This number becomes 1. Okay. So far, so good.
Yes, sir.
Yes, sir.
Yes.
Yes, sir.
So initially I make a count which will be equivalent to 1. Why I make the count variable equivalent to 1? Because even a number 0 in decimal require 1 bit in binary. In binary it means 0. Another number 1, if I take 1 in decimal, in binary it should be represented as bit number 1. So for even there can be not be any digit represented in 0 bits in binary, right? So at least 1 should be there. So using that logic, I specify count is equal to 1 initially. In this 16, how many divisions have take place with respect to 2? 2 into 8, 16 one time. 2 into 4, 8 2 times. 2 into 2, 4 3 times. 2 into 1, 2. 4 times. So totally 4 times. If I have, it is giving me 5 digits. Okay. Similarly, I do for here in 12. In 12, see how many divisions are there going to be in with respect to 2.
3,
2
sir.
into how many times? Yes, correct. You're correct. 2 into 6. And I was not interested in this reminder, but just I'm writing it. 2 into 3 again, 0. And 2 into 1 is 1. 2 into 1, remainder 1. And my binary digit will be 1100. So this will be written as 1100. So here when I get a number 12, I need to divide it by 2 3 times. If I divide 3 times, my output is actually 4. If I divide 4 times, my output is actually 5. So if I divide n times, what will be my output?
4.
N plus 1, right? If I divide n times, my output will be n plus 1. Am I right?
Yes, sir.
Yes. So based on that logic, I am proceeding. So that I need to do plus 1, right? So initially I started with count is equal to 1. So it's not going to count from 0, it's going to count from 1. Now I'm going to use non-recursive algorithm for solving it. I can also solve it using recursion because I need to do as a function repeatedly until an initial condition meets. The initial condition is n equal to 1. Until that is meeting, I can repeat. But by using non-regression, I can use looping operation where I take n while n is greater than 1. If n is greater than 1, what I should do is just to make count is equal to count plus 1. Just to say count is equal to count plus 1. Next, n is equal to n divided by 2. This n divided by 2, I'm going to write in separate fashion. Let it be n divided by 2. Now I come in here and then ask you a question, right? What is 4 divided by 2? You say with respect to C program.
2, sir.
2. You are saying it is 2. What is 5 divided by 2?
2, sir.
2, sir.
2. When it is in C program, it is 2. When it is in Python,
2.
when it is in Python, in Python the data type changes with
2.5.
respect to the operation. So 5 by 2 will give me 2.5. It will become a floating point number, right? 2.5. It becomes 2.5. You see here, I'm having a number 3. When I divided 2 and 3, it is giving me a result 1. It is not giving me any separate result. It is giving me a result 1. It is not giving me 1.5. So what I should do? I should not take this decimal number. Am I right? Am I right or wrong?
Yes, sir.
Yes, sir.
So in
Yes,
this
sir.
algorithm, I cannot say that my algorithm should be run in Python only. It should be run in C only. Like that, I cannot say to my user. For my user, he knows only coding. He can do it in any coding language, but I should give only algorithm. So what I should do is I need to explain him like whether it is going to be this bracket, whether it is going to be this bracket or this bracket. So what is the bracket I am writing here?
Floor and seal.
Great. It is floor and steel. If I write it as 5.8 here and the same 5.8 here, right? This will be equivalent to floor. Floor of 5.8 is nothing but an integer, the smallest integer closer to 5.8. What is the smallest integer? Very close to 5.8, that is 5.
5.
5.
And what is the largest integer closer to 5.8?
6.
6.
6.
So this is nothing but seal. This is called a seal operation. And this is actually floor operation. This is floor. Right? Now, if I give a 2 and a 3, if I want to divide this 3 by 2, whether I get a result 1.5 and 1.5 is converted into 1, whether it is floor or seal.
Floor, sir.
Floor, sir.
It is converted into floor. 1.5 is converted to 1 means that it is a floor operation, right? So now what I have to do here, shall I put
Yes,
here
sir.
floor n by 2 should be done as floor. So far so good. Why I am doing this?
Yes, sir.
Yes,
Sir?
sir.
Yes, somebody is asking question.
Sir,
Yes.
sir, we can also do n by 2 in percentage by 2.
N by 2 or n percentage 2, anything you can do. Number of times it is going to be
Sir,
divide. But when you do n percentage 2, what will be the problem is how you will be identifying this one. What will be the initial condition you will keep here while n greater than 1? How will you be keeping this? Can you understand what I am saying?
sir, I'm saying that n by 2 minus n percentage by 2, sir.
N by 2 minus n percentage 2. Why we are doing that?
Sir, for finding that value, sir.
So I was not interested in this value. If I want this value, I need to find n modulus 2 and then I can find this binary representation of 16. But I don't want this representation. I need to just count how many binary digits will come. Right? I am getting the results like 1 1 1 1 1, 5 ones or 5 zeros or 1 1 1 1 and 4 zeros. Anything what I get, let it be. But I just only needed how many numbers came. That's it.
So we need binary, not then why you write it decimal, sir?
Come on.
When n is equals to n by 2,
Yes.
it's become 6, right, sir? 6.
Yes.
then we need the binary, right, sir?
Okay. I'll take 12. Let 12 come here. Now count is equal to 1. While 12 is greater than 1. Right? While 12 is greater than 1, what does it mean? Condition is true or false? True. Next, count is equal to count plus 1. I'm incrementing. Someone increment the count. 1 plus 1 will become 2. Right? Yes. Now 12 is equal to, that is n is equal to 12 divided by 2. What will be the result? 6.
6.
Now 6 will again go to the while loop. 6 is greater than 1. Again it is true. Increment the count. What is the current value of count? 2 plus 1 is 3.
3.
Next, 6 divided by 2. Answer will be
3.
3. Again 3 will be going while 3 greater than 1. Increment the count.
4.
3 plus 1 4. 3 divided by 2. What will be writing here? 3 by 2 is 1.5. But I am taking floor. So 1.5 becomes 1. So again go to the while 1 greater than 1. What is the result? 1 greater than 1. 1 greater than 1 is false. So when I say 1 greater than 1 is false, I'll come out and then I will return here. Return
Count.
count. The question what you asked is, we are not getting here 1100. I don't want what is that. I don't want what is 1100. I can also put here some variable and say n mod 2 and then store that variable and then give the result. But in the question that is not asked, in the question they asked only how many digits are there. They didn't ask what is the digit. They didn't ask whether it is 1 or 0. They didn't ask anything like that. So we should not waste our time complexity in doing that. Hope I made it clear now, right?
Yes, sir. Yes, sir.
Yes, great.
Thank you.
Now this is fair. So the algorithm is good, right?
Yes, sir.
Yes, you can take screenshot. I'm going to erase these rough portions. Shall I?
Yes, sir.
Yes. Now, before erasing this rough portion, I want you guys to understand the theorem, the logarithm theorem. That is not a very big theorem, just a understanding about the division of the by 2. Right? Now, I will ask one question. Just say me like what is coming in your mind when you do this. Right? I give a number 12, and if you have a for loop for I is equal to 0, I less than 12, I plus plus, and some floor division is going on inside. That is some big O of one operation is going on inside. Now you say how many times this for loop will execute?
12.
12 times, sir.
12 times. Similarly, if there is while loop also the same thing will happen, right? Now the small change here, I put here 12 greater than 0,
I
I
minus.
minus minus. So what will be happening now?
I think so. Same.
Same 12 times, right? So this is very nice. But when I come here to these kind of operations, when I give 12, it is the first time it becomes it is 12. Second time it actually made a one half of the item. Next 6 by 3 becomes even more small, and 3 by 3 it becomes 1, right? So only the 12 is now only 1, 2, 3, 3 times, right? Similarly 16 it becomes only 4 times. Now we need to identify in what pattern it is actually being reduced. That we need to identify. Here it is decrementing every time by 1, so I know that it is going to be exactly the number of times in which it is going to be iterated. But here the case is not like that. Each time the iterator variable is decreased by half, right? So can anyone say what can here you say if input is n, output is big O of n. Here the input is n, what will be the output? Can anyone understand how to do that?
Same big of n.
If you say big O of n, then this 12 should iterate actually 12 times, but it is iterating only 3 times. 12 is iterating only 3 times.
Big of 12.
So, it cannot
N by
iterate.
2.
Come again? Whether
Sir,
come
we
again?
want
She said n by 2.
Okay, if it is n by 2 also, for 12 by 2 it is 6, it should come 6 times, right? But it is only 3 times. Now we will experiment how it is actually happening. Okay, now I'll explain you how it is happening. Now I'll
Big
write
of
another
log n.
for loop. Yes, who is that? Prashwant. Okay, great. I'll explain how it comes. Okay, for I is equal to 1, I less than or equal to some n. Okay, I star equal to 2. I put here I star equal to 2. All right. Now, again, I come here. Some big O of one operation will be there inside. Big O of one operation is available here. Now, what will happen? First, in the first iteration, what is the I value? Say me what is the I value here initially.
1.
1.
So, I will start from 1, 2, 3, 4, like that. Sorry, the iterator variable iter is 1. This is iter. And the I value will be initially I will be in the first iteration I will be 1, second iteration I will be 1 into 2, 2, third
2.
iteration
4.
4, and the next 4 into 2 8, and dot 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 it will be going, right? I'll be starting the iteration from 0 because usually we'll be studying only 0 from starting from 0, so that will be better to understand. So in the 0th iteration, I value is 1. In the first iteration, I value is 2. Second iteration, it is 4. Third iteration, it is 8. Right? In dot dot dot, it will be going. Now, can anyone say what is the logic for this? Logic. To find a logic between the
2
iter
power n
variable
minus 1.
and the I value. I value can be considered as 2 power iter. If I say 2 power iter,
2 power
2 power iter is nothing but the value which I am having here. This value iter. 2 power 0 is 1. 2 power, this is 2 power 1. This is 2 power 2. And so on. This is 2 power 3. I am making it clear.
Yes, sir.
Yes, sir.
So let me erase it and write somewhat more clearly. So when I have some variable to be distributed here, if I have like this, it is 2 power 0, 2 power 1, 2 power 2 and so on. If I was able to find if n is there here, if I have some value like n here, what will be here? If I was able to find that, then I was, my problem is done. That's what the thing I have to do. If I, in what iteration it will be actually getting solved. Now I'll take a very simple example, taking n value is equal to 32. N is equal to 32. Now if I take n is equal to 32, if I increment 1 by 1, 32 times it need to execute. That is what the normal thing, then I say O of 32. If it is not like that, if I was beginning from 1, and each time I say I star equal to 2. So what will be my first one? 2 power 0,
that
2 power 1. Next,
2
2
square,
power
2
2.
cube,
Up to what I have
2
to go?
to
2 power
Up to
5.
what?
2 power
2
5.
power
Very good. Up to 2 power 5. Why up to 2 power 5 I should go?
2 power 5,
32.
32.
Yes, 2 power 5 less than or equal to 32. If I say up to 2 power 5, I have to go. Right? So 1, 2, 3, 4, 5, 6. Within 6 iterations, I got 2 power 32. Within 6 iterations, I got 2 power 32. Right? Now, if n is equal to 32, you are coming in 2 power 5. If n is equal to 64, you will be going for 2 power 6. Right? So for this n value, you are able to find some I here such that it is getting equivalent to that largest number. Right? So if I can also, so I'm having here like n, which will be, if it is 32, I'm getting here 2 power 5. If I was having here n, shall I put some variable like 2 power I? I is not known. Just to have some variable I,
Yes,
right?
sir.
That is equal to 2 power 5, n is equal to 2 power I. So if I was able, so if I give a number 32, up to 5 number of times I need to go, or 5 plus 1 number of times I need to iterate. So if it is a number n, I should go for I plus 1 iteration, right? So if I find the value of I, then I can find how many times that particular loop will execute. Am I right?
Yes, sir.
Yes, sir.
Yes. Now going for the final answer, this 32 I will write like, I'll take log on both sides. Log
32.
32 is equivalent to, I take log to the base 2. Okay, I take log to the base 2.
Log
Log base 2 of
5.
2 power 5. So the basic logarithm is, if you take log of a particular value and take power, these 2 and the 2 will get cancelled. This 2 and this 2 will get cancelled, and you will get the result as just 5. You will get this
5.
2 and 2 will get cancelled and get the result as 5. So if I take the same thing over here, right? If I get the same thing over here, then what I can actually do? Log n is equal to, take log base 2 n is equivalent to log base
Base
2
2
2 power I.
to power I.
So what will happen? This entire log term and the 2, this log 2 entirely and this 2 I will cancel out. So what will be the I value now?
Value is I.
I is equal to log base 2 n. I is equal to log base 2 n. So if you multiply a number, if I go for I is equal to 1, I less than equal to n, I star equal to 2, the answer will be I log base 2 n. Number of times that iteration will go is I log base 2 n, or if it is I plus 1, I have to write like log base 2 n plus 1. But that plus 1 I need not represent by, because when I do the asymptotic notation, constants can be eliminated. Right? Constants can be eliminated. So my result will be log base 2 n1. Right? Now, using these kind of examples only, you should say what is the complexity of finding number of digits in binary. Right? So, what will be the complexity of finding number of digits in binary?
Log n.
Log n. But here I explained using multiplication. I'll also explain you with respect to the division also. With respect to division also, I'll explain. Only the reverse term, right? If I get using the division term, right? Right? I'm having a number 16. Now you say me, I'm
Sir,
getting a
if
number
n is
16.
different means what we have to do, sir?
Yes. Come
If
again.
n is equal to 32 means it takes 2 power 5
Okay.
iteratives. Then n is equals to another one means what we have to do, sir?
Say you should say a number.
33,
Like
sir.
1. Yes, sir.
N
Like
is
that.
equal to 33. Okay. That number can I do?
Yes,
Yes,
sir.
sir.
N is equal to 33. Okay. 10 with 33 also I'll get the same thing. Why? Because the for loop will be for I is equal to 1, I less than or equal to 33, I star equal to 2. So initially it will be 1, next 2, 4, 8, 16, 32, and after 32, this I star equal to 2 will give me 64. 64 less than or equal to 33 will be giving me false. 64 less than or equal to 33 will give me false. So my result will be the 32 one. The 2 power 5 only is my result. Am I making it clear?
Yes, sir.
Yes. So let me go with the division kind of. I am having a number like 16, right? So initially my number becomes 16. Now the for loop is not like this. My for loop is, it is not a for loop. Just take a while loop itself. Until n becomes 1, I have to proceed. Okay, n is equal to n by 2 and 2 and so on. I should proceed. Initially it is 16. Condition true. Next 8. Next 4.
4.
Next 2. Next 1. When it comes 1, I should stop. When it comes 1, the condition fails and I should stop. And how I can represent this is, this can be represented as 2 power 4, 2 power 3 is 8, 2 power 2 is 4, 2 power 1 is 2, and 2 power 0 is actually 1. Right? Either you calculate from 0 to 4, 1, 2, 3, 4, 5, it becomes 5 digits, or you calculate from 4 to 1, 4, 3, 2, 1, 0, 5 digits. Both are same. When you do the multiplication or division, the answer is going to be log base 2 n1, because I'm going to multiply by 2 or divide by 2, so I get the same. Right? Am I making it clear?
Yes, sir.
Yes. So what is the complexity of finding number of digits in binary?
Log 2n.
Of log n.
Complexity of finding number of digits in binary is not log n, it is log base 2 n. So always say like that. Why? Because there is a difference between saying log n and log base 2 n. Why? Because the default
Log n base
log
2.
base is 10. The default log base is 10. Hope you know that. Right? So always say it as okay, sorry. Say it as log base 2 n. Complexity of finding number of digits in binary for a given decimal number is O of log base 2 n. Base 2 n went down, so I write it here again. Log base 2. Right? So this is the case. Now a general question, let me see how many of them are answering that. I write here for I is equal to 1, I less than or equal to n, I star equal to 3, and inside I put a big O of 1 operation. What will be the result of this?
Same.
Uh, Same in the sense?
Base
Base
3,
3.
sir.
Yes, who is that? Base 3. That is big O of log base 3n. Why I am saying base 3? Each time it is going to increment by 3. So I can just take log base 3. If it is 4, what you will say log base 4. If it is 6, say log base 6 and so on. Right? Now for any for loop, you are able to categorize how the complexity will go on, right?
M.
Yes. So just to understand how the log works. So if you understand the log, how the log works, then everything goes easy, right? Shall we proceed?
Yes, sir.
Yes, sir.
So we have completed the recursion. We have completed for the 4 recursive algorithms what we have planned initially. Sorry, non-recursive. The 4 non-recursive algorithms what we have planned earlier. We have completed those non-recursive algorithms. Now we will be going into the recursive algorithm, right? We will be going an initial factorial and then we will be proceeding in the subsequent. Okay. Shall I erase this?
Yes, sir.
Recursion algorithm. So what is the definition of recursion algorithm? A function called itself is called
Itself.
recursion. Recursive function. Conditions for recursion. The constraints for recursion algorithm. It should have a
Sir, your voice is breaking, sir.
check now. Is it okay?
Breaking, sir.
Too,
Only
too
5 minutes.
low, sir. Too low.
Too low. I'll increase my volume then. Can you hear me now?
Yes, sir.
Yes,
Yes,
sir.
right? Yes. So I just here increase the volume. So now it will be clear. So a recursion function should have a recursion algorithm should have a stopping function. It should have a stopping criterion or initial condition. So what is that? You said right up to what I have to proceed this function. Initially for Euclid's algorithm also until n becomes 0, I should recursively call the GCD of n comma m order. That is initial condition or stopping criterion. Next, it should have a recurrence relation. It should have a recurrence relation. We will see what is the recurrence relation. We have already seen one, that is GCD's recurrence relation. What is GCD's recurrence relation? GCD of m comma n is equal to GCD of
N comma M modulus N.
yes, great, n comma m mod n, right? That is what the recurrence relation of GCD, right? Similarly, we will be only when these two conditions exist, we can say that any function can be solved using recursion, right? In recursion, we are going to solve 4 algorithms. Algorithm number 1 is factorial. We already seen this. What are the algorithms? Fibonacci series. Third is traverse of Hanoi. And fourth is the same, finding number of digits in Hainai or a given decimal number. Hope you are even more better than me for finding the algorithm or writing programs at this at this point of view. But the analysis that actually matters. As you said in one of the quizzes in the morning session, we have three ways of analyzing a recurrence relation, right? That is substitution method or recurrence tree method or master's theorem. We'll be seeing all the three on these four algorithms and know how to find the time complexity of recursive algorithms, right?